Hi everybody, this video covers section 4.4a, finding equations of a line. In this video we're going to talk about how to find the equation for a line when you are given a slope and a point that the line goes through. We're also going to learn how to find the equation for a line given 2 points that are on that line. Because of course if you have 2 points, then you have everything you need to define the line. Now, to write an equation for any line, you need basically 2 things. The first thing you need is the slope. You need to know how steep it is. Secondly, you need to have a point that that line goes through. Once you have those 2 things, you can immediately write down the equation for the line. And you would write it down like this. If this is the point, if this is the point on the line, then the point is going to be defined by this coordinate x1, which is the number. It's the x value for the point. And y1, which is also a number, is the y value for the point. And the equation will be the variable y minus y1, and that's going to be equal to the slope, m, times the quantity, x, which is our variable, minus x1, which of course is just the number representing the point. And we call this type of equation the point-slope form for the linear equation. So now we actually have 3 forms for the same linear equation. We can actually have a standard form. We can have the slope-intercept form, which we talked about last time. And now we can have the point-slope form. And the point-slope form is the second most useful form for a linear equation because if you know the slope and if you know a point on that line, then you can immediately write down the equation. So here we are. We have a slope, we're going to call it m. We have a point, we're going to call the x-coordinate x1, the y-coordinate y1. And this is the point-slope form for that particular equation. So let's look at this in terms of an example. Suppose that we have a line, and we know that its slope is 4, and we know it passes through this point, 2, 5, where the x-coordinate is 2 and the y-coordinate is 5. Well, once we have these things, we can immediately write down the equation for the line in point-slope form. It's going to be y minus y1, which in this case will be 5, and that's going to be equal to the slope, which is 4, times the quantity x, which is again our variable, minus x1, which in this case happens to be 2. This is the point-slope form. Now, if we solve for y, we are going to have this. We will have y is equal to 4x minus 8 plus 5, which will be minus 3. And by solving for y, we will actually have y is equal to 4x minus 3. And notice that this is in slope-intercept form, where this again is the slope, and then that is the y-intercept. Now we are also going to talk about writing linear equations when you have 2 points. So here are our 2 points, x1, y1, and x2, y2. And the very first thing you're going to do is compute the slope using the slope formula. So let's suppose that we actually have 2 points that the line goes through. And let's suppose those points are given by the coordinates -2, 2, and 4, -1. Well, then we can let this coordinate be x2, y2. This coordinate be x1, y1, and using our slope formula, we will have that m is equal to y2, which is minus 1, minus y1, which is minus 2, over x2, which is 4, minus x1, which is -2. And then we will have, for the numerator, -1 minus 2 is -3. 4 minus a -2 is just like 4 plus 2, so we're going to have -3 over 6, or 1/2. Once you have that, you can use either x1, y1 or x2, y2 to write down the equation in point-slope form. For example, you can use x1, y1, and this would be your equation. It would be y minus y1, which is 2. That's going to be equal to our slope, which is -1/2. Times the quantity x minus x1, which was, since x1 is -2, would be x plus 2. Or if you wanted to, you could use you could use this point, which is what we called x2, y2. Then you would have y minus -1, which is like y plus 1. That's y2 right there. And that's going to be equal to 1/2 times the quantity x minus x2, which was 4. So you can use either point. It does not matter which point you use when you apply the point slope formula. As a matter of fact, when you go ahead and you solve for y, you will find that in this particular case, solving this equation, we will find that they result in the exact same equation in slope-intercept form. So take a look at this. If we use the distributive property to multiply this out, we're going to have y plus 1 is equal to negative 1/2 x minus negative 1/2 times 4. That's going to be equal to y plus 1/2 is equal to negative 1/2 x minus a negative 2. And that simplifies to y is equal to negative 1/2 x plus 1. Over here, distributing the 1/2, we're going to have y minus 2 is equal to negative 1/2 x plus negative 1/2 times 2. That simplifies to y minus 2 is equal to negative 1/2 x. Negative 1/2 times 2 is just negative 1. And then when we add 2 to both sides, we get the exact same thing. Y is equal to negative 1/2 times x plus 1. So they're essentially the exact same equation, just approached from a different way. Okay, so let's look at a few examples. I only have 4 examples that I need to show you because there's not much variation in this particular homework. But here's the first one. The first example is to find the equation and they want it in slope-intercept form for this line with the given slope, which is negative 1/9, that passes through the point with the given coordinates, and our given ordered pair is 3, 5, 6. So we have that m is equal to negative 1/9, that's our slope, and we have that our point is 3, 5, 6. So m is going to be negative 1/9, x1 is equal to 3, and y1 is equal to 5, 6. So all we need to do now is apply the slope, is apply the point slope form. And here it is. So we will have y minus y1, which is 5, 6. And that's going to be equal to negative 1/9 times x minus x1, which is 3. And so this is the point slope form for this particular number. Now we need to convert to slope-intercept. So we convert to slope-intercept by solving for y. And this means we want to isolate y on one side of the equation and everything else on the other side of the equation. So first, let's go ahead and just get rid of the scripting symbol by using the distributive property. And if we do, we will have y minus 5, 6 is equal to negative 1/9 x. And then it's going to be, and that's going to be minus negative 1/9 times 3. And that will give us y minus 5, 6 is equal to negative 1/9 x. And then 1/9 minus negative 1/9 times 3 is negative 1/3. So we're going to have minus negative 1/3. And then we will have y minus 5, 6x. Oh, I'm sorry, y minus 5, 6, and that will be equal to negative 1/9x. And minus negative 1/3 is just plus 1/3. And now we can add 5, 6 to both sides. And that will give us, let's do this up here. And then, when we add, the 5, 6 will cancel here. We will have y is equal to negative 1/9 x plus 1/3 plus 5, 6. Now, we still need to add this apart, and to do that, we need to find a common denominator. And we can do that by multiplying both the numerator and denominator here by 2. And if we do that, will give us that y is equal to negative 1/9 times x plus 2, 6, because 1 times 2 is 2. 3 times 2 is 6. Plus 5, 6, which will equal negative 1/9 times x plus 7, 6. And so our answer in slope-intercept form will be y is equal to negative 1/9 x, and that should be a 7/6, not a 7/2, plus 7/6, and this should be our answer. So you can punch that into Hawks and you would be correct. And of course I have it worked out in the slides. So there is it in point slope form, and then to solve it in slope intercept form, it's worked out right here as well, which would give you, again, y equals negative 1/9 x plus 7/6. Here's another problem of the exact same form. Here we want to find the equation in slope-intercept form of the line with the given slope that passes through the point by the given coordinates. And the given slope is m is equal to 0. And the coordinate is, again, x1 is equal to 5, and y1 is equal to negative 6. And once again, we are going to use the point slope form. And so we're going to have y minus y sub 1, y minus y sub 1, which in this case is negative 6. And that's going to be equal to m, which in this case is 0, times x minus 5. Of course, this is just nothing more than 0x minus 0 times 5. 0 times x is 0, 0 times 5 is 0, so all of this just happens to be 0. So we will have, on the left-hand side, we have y minus negative 6, which is just like y plus 6, and that's going to be equal to 0. Now, to put this in slope-intercept form, all we have to do is solve for y. And when we do, we will have y is equal to negative 6. We'll subtract 6 on both sides, and we'll end up with y is equal to negative 6. And this is in slope-intercept form. We have y isolated, and it happens to be equal to negative 6. And as you can see, this is the equation for a horizontal line. Okay, moving on to example 3. Here we have a situation where we have 2 points, and we are asked to find the equation once again in slope-intercept form of the line passing through the points with these two given coordinates, negative 3, 2, and negative 4, negative 5. So the first thing that we need to do when we're given 2 points is first we have to compute the slope, because we cannot come up with an equation for the line unless we know what the slope is. So we're going to compute the slope, and what we're going to do is we're going to let this point be x1, y1, and this point be x2, y2. Then we are going to have that m is equal to y2, which is 2, minus y1, which is minus negative 5, and then x2, which is 3, negative 3, my apologies, minus x1, which is negative 4. Okay, that reduces to 2 minus negative 5 is just 2 plus 5. Negative 3 minus negative 4 is negative 3 plus 4. And that will give us in the numerator 7 and in the denominator 1. So it turns out in this case m is equal to 7. Okay, so once we know the slope, we can go ahead and write the equation in point slope form. And we can use any point, and it doesn't matter which point we use. We can either use this point or we can use this point. It doesn't particularly matter. The only criteria might be which one makes the math easier or makes the arithmetic easier. So we're going to go ahead and use this point right here. So doing the substitution and using this point right here, we will have y minus the y coordinate over here, which is, where's my thing there, which is 2, and that's going to be equal to the slope times x minus, and we have a negative 3 minus negative 3. Okay, well, we can simplify this just a little bit, and by getting rid of by dealing with this subtraction of a negative number, and that will give us y minus 2 is equal to 7 times, and since x, and notice that x minus negative 3 is the same as x plus 3. Okay, so here is our equation in slope-intercept form, and there it is again. Okay, once you've done that, we need to convert to standard form, which is what we have here. So this is what we started with. What we can do is we can add 2 to both sides. Well, first thing we can do is we can distribute. 7 times x is 7x. 7 times 3 is 21. Now I can add 2 to both sides, and I will get y is equal to 7x plus 23. That should be a plus. And there we are. We're done. This is the equation in slope-intercept form. Okay, for my last example, at least in this part, we have this problem. We have a lab equipment salesperson, and it turns out that her weekly income depends upon the amount of her sales. She starts off with a base salary of $410, and then she earns plus 9% of her weekly sales. And we need to write a linear equation for her weekly income for sales of X dollars. And it's going to be in the form I is equal to M times X plus B, where of course X is the amount of her sales in dollars. So how do we handle this? Well, first we notice that she draws a fixed salary which does not change with X of 410. So that's no matter whatever she sells, she gets 410 bucks, and that is pretty much what B would be. Okay, because it's fixed. If X is 0, she will still get B. All right. Well, let's let X be her sales in dollars. Then the amount of money that she makes for after X dollars of sales is going to be 0.09 times X dollars. So this is the function of X, and this is a constant. So her income is going to be equal to the amount of money she makes per dollar, which of course is 0.09x, plus her fixed salary 410. And here it is. So that is the answer for this particular example. Okay, with that, let's go ahead and look at some Hawks problems. I think there's only 3 that we need to look at. So here we are at our Hawks dashboard. I'm going to go ahead and click on practice. And this is, well, here we go. This is the exact same problem. So let's try a similar problem because that's the one we just did. Okay, here we go. Here we have a textbook salesperson. His annual income depends upon the amount of his sales, and his salary is going to be $13,500 plus 5% of sales. Okay, and in terms of sales, we're talking X dollars. All right, cool. So basically, 5% corresponds to 0.05. So for every dollar he sells, he's going to receive 0.05 for every dollar he sells. So if he sells X dollars of stuff, he will receive 0.05 times X dollars. On top of that, he's going to receive the base salary of $13,500. And that is the equation. Remember, the conversion from percentage to a decimal is always dividing by 100. So 5 divided by 100 is 0.05. Now let's see if I'm right. Me right? Nah, that can't happen. We'll have I is equal to 0.05x plus 13,500. And there we go. Okay, let's look at the next problem. Okay, so here we need to find the equation in slope-intercept form of the line with the given slope that passes through the point of the given coordinate. So the given slope is going to be 5/9, and the coordinate that we're looking at is 0.47. Okay, so in this particular case, our slope is going to be 5/9, so m is equal to 5/9. Our coordinate is 0.47, so this will be x1, this will be y1, and that means that x1 is equal to 0, y1 is equal to 4/7. Okay, so we start off, so we're going to apply these numbers, or substitute these numbers in the point slope form, which is y minus y1, where y1 is, that could be that number right there. That's going to be equal to m times the quantity x minus x1, which of course is 0, which is going to make life easy for us. So we are going to have y, that should be a 7, minus y1, which is 4/7. That's going to be equal to 5/9 times x minus x1, which is 0. Well, x minus 0 is just simply x. So we can write this as y minus 4/7 is equal to 5/9 x. Because I'll go ahead and we could distribute this, which would be, and so we would also have 5/9 times 0. However, this is just 0, so now we're going to have y minus 4/7 is equal to 5/9 times x. All right, so this is our point slope form representation. Now to get this into slope-intercept, we need to isolate y. We need to get y on one side of the equation and everything else, namely the 4/7 on the other side of the equation. And we would do that by adding 4/7 to both sides of the equation. Plus 4/7 here, plus 4/7 here. These will cancel. We will have y, and over here we would have 5/9 times x plus 4/7. And we are done. This is slope-intercept form. Y is equal to some number times x plus some other number. There we go. Okay, so let's see what other type of problems we have here. Okay, so here is a problem where we are given 2 points and we need to find the equation for that particular line. It says find the equation, once again, in slope-intercept form of the line passing through these points with the given coordinates. Okay, so the first thing we need to do is express this, is find the equivalent equation in point slope form. So let's start off with our points. We have 2 comma minus 1, 5 comma 2. Those are our 2 points. The line passes through those 2 points. The first thing we need to do is find the slope. And we want to use the slope equation. That's going to be m is equal to y2 minus y1 over x2 minus x1. And we want to decide which one we want to call x1, y1, and x2, y2. I would recommend that we call this one x1, y1, and this one x2, y2. Then we're going to have that x1 is equal to 2, y1 is equal to -1, x2 is equal to 5, y2 is equal to 2. All right, making the substitutions, we have that y2 is equal to 2, minus y1, which is -1, divided by x2, which is 5, minus x1, which is 2. The numerator, we have 2 minus the -1. That's just like 2 plus 1. 5 minus 2 is equal to 3. 2 plus 1 is equal to 3. And that's going to be 3/3. So our slope is going to be equal to 1. That makes life a lot easier for us. Okay, so now that we have the slope, we can use any one of these points that we want and substitute it into our point slope equation, or point slope form, which is, again, the variable y minus the y coordinate for whatever point you use. That's going to be equal to the slope, which is m, times x minus x1, where, again, x1 is the x coordinate for whichever point you choose. Let's go ahead and choose 5, 2. Let's just go ahead and choose that one, just for kicks. In that case, we are going to have y minus 2. That's going to be equal to 1 times x minus 5. Okay, the 1 doesn't really do anything for us, so this is the same as y minus 2 is equal to x minus 5. Now remember, to get it in point slope form, all we need to do is isolate y. Okay, and to do that, we need to add 2 to both sides. And when we do, these cancel. We have y is equal to x minus 3. And this is the equation in slope-intercept form. So we can come over here. We can type in y is equal to x minus 3. And there you go. You have it done and correct. And that pretty much covers all the material in this particular lesson. Once again, if you have any questions, please feel free to reach out to me. And this is Bob Boyle, signing off.